Okay, so now we want to solve a little more complicated problem. Here we have three charges, and we have Q1, which is a positive charge. We have Q2, which is a negative charge, and those are 0.3 meters apart. And then we have Q3 over here, which is also a positive charge, and it's 0.5 meters from Q2, which makes it 0.8 meters from Q3 all the way over to Q1. And we want to find the force, the net force on Q3 due to the other two charges. So what we're going to do is we're going to break it down into two subproblems. We're going to find the force on Q3 due to Q1. These are both positive, so they'll repel each other, so the force on Q3 will be to the right. And then we're going to figure out what is the force on Q3 due to Q2. Those are opposite charges, so they will attract, so there'll be a force on Q3 to the left. We'll find those two forces, and then we'll use Newton's second law to find the net force. Okay, so to start, we are going to find the force on Q3 due to Q1. Okay, and remember the distance between Q1 and Q3 is actually 0.8 meters, so we have to take that into account. All right, and this is 2 microcoulombs, and this is 2 microcoulombs. So when we plug in those numbers, and you guys have already got a lot of experience doing this since you have got the first problems in this set solved. The force on 3 due to 1, so this is how we use our subscripts. The force on 3 due to 1 is K Q1 Q3 over d squared. Plug in the numbers there, and it turns out to be 0.056 newtons. Now, because Q1 and Q3 are both positive, those forces repel. So the force on Q3 is away from Q1. It's to the right. So the force on 3 due to 1 is 0.056 newtons to the right. All right? So that's our first subproblem. We found the force on 3 due to 1. Now, let's find the force on 3 due to charge number 2. Okay? The distance between those centers is 0.5 meters, and Q2 is negative 4 microcoulombs. Q3 is 2 microcoulombs. So we can plug in all those numbers to our formula and find the force on charge 3 due to charge 2. Remember, we always use the absolute values, so the size of the force is 0.288 newtons, and that is pointing to the left because this is a negative charge and this is a positive charge, so they're attracted to each other. So the force on charge 3 due to charge 2 is 0.288 newtons to the left. It's pointing this way. Okay? Now we're going to put those two things together. Here's Q3. It's what we're interested in. We know there's a force going to the right due to charge 1, and that's 0.056 newtons. We know there's a force going to the left due to charge 2, and that's 0.288 newtons. Clearly, this is the bigger force, and so the net force is going to end up going to the left. So to find the net force, we take the force to the right minus the force to the left, so that's the 0.056 newtons minus the 0.288 newtons. So the difference is 0.231 newtons. And since the difference is heading to the left, we make it negative. And so the net force on Q3 due to the other charges is 0.231 newtons to the left. Okay? So if you have more than two charges, you just work out the force on whatever charge you're interested in from each of the other forces, and then you add the forces together, just the way we've been doing all year long. Okay, so the first problem here is going to step you through that. It's going to have you find the force on one due to another, and then find the force on one due to the third charge, and then find the net force. And then the last one puts it all together in one problem. Okay, good luck.